Throughout the centuries, artists have developed many effective techniques to convincingly convey shapes in very noteworthy manners. During the past 2 decades, non-photorealistic rendering techniques have greatly enhanced the shape depiction by making objects more visually appealing. But most of them are lacking the ability to correlate shape enhancement functionalities with surface feature variations. Therefore, depicting surface details while keeping non-photorealistic styles unimpaired, remains as a challenge. This research introduces a new framework to enhance NPR shape depiction, taking into account the combination of shading and lines with respect to surface geometry features. The first step in our NPR framework is to estimate the surface curvature. This is achieved by computing an image space curvature map using an enhanced normal buffer and depth buffer, and then remapping the estimated mean curvature using a nonlinear mapping function. The proposed algorithm reduces the noise that generated often during curvature estimation. It also conveys the curvature information in a coherent and stable manner, and hence avoiding discontinuities between surface curvatures regions. We then presented a new technique called geometry-based shading that enhances the surface features in a wide variety of non-photorealistic rendering models. We explained its principle by starting from the reflected radiance equation. The main idea is to adjust the reflected light intensity per incoming light direction. This function depends on surface curvature and material characteristics. As an example, we show diffuse and specular materials are manipulated to attend surface features with our scaling approach. Now, we reformulate 3 of the most common NPR shading models with respect to the reformulated equation. Firstly, we demonstrate the result of the enhanced Blinfong shading model. It allows the user to enhance each term of the shading model separately. The enhanced Blinfong shading model provides better depiction of surface details. Here, the technique is applied with cartoon shading. The enhanced model is beneficial for depiction of fine features, while keeping the cartoon style unimpaired. Finally, the technique is used to reformulate Gooch shading. The enhanced model correlates the cool to warm shading to geometric surface features. For example, all parts of the Armadillo 3D model are more apparent because convexities and concavities are depicted in cold and warm colors respectively. Geometry-based shading technique also enhances the shape depiction using unsharp masking normal operator. It used to amplify the sharpness of surface normal in order to reveal the fine surface details. Geometry-based shading technique combines the advantages of normal enhancement and curvature shading to enhance shape depiction. The dual enhancement is most effective in conveying the illumination characteristics, material, and surface features. In order to depict shapes through lines, feature-based line drawings technique has been proposed. It depends on combining different types of feature lines and allows the user to control each of them independently. For example, it convolves the depth buffer to obtain the occluding contours, the enhanced normal buffer to obtain the surface ridges, and the enhanced curvature buffer to obtain the surface inflection. The benefits of this technique comprise low computation cost and providing a richer range of styles in a coherent manner. Finally, the proposed NPR shape depiction framework combines the geometry-based shading technique and feature-based line drawings technique in order to convey the continuities and discontinuities of shape features at once with respect to surface geometry features.